Welcome everyone. Let's wait a couple of minutes for people who might still join us, for more people. Meanwhile, is there any questions from chapter 1? Any problem you might have encountered from the suggested problem list? Or any question that you might have concerning the theory? The last part that I would like to cover today from chapter 1 is a couple of applications from the cross product. We haven't done that yet, so I'd like to finish that up for the first part of today's meeting, and then I'd like to move to chapter 2. So is there any questions on chapter 1? Ah, okay. So I take it as there is no question, everything is okay? That's pretty cool. Okay, so let's go over some simple application of the cross product. I would like to do it using the conventional way of doing them using 2D, and then I would like to show you the technique of using matrices, which might look a little bit overkill as you do 2D problems, but this is the method that will be very useful as you switch to 3 dimensions. So I would strongly suggest that you develop both techniques and that you master both of them. Okay? So let's look at a simple example. Let's imagine we have a vector A. Let's say the length of vector A is 2. Let's not worry about the units right now. And another vector B, whose magnitude is 3. And let's say B is defined as with an angle of 30 degrees with respect to the direction of A. So, first question. What is the direction of A cross B? Is it into the board or out of the board? That means towards the whiteboard or coming towards us. Anyone? 90 degree right. 90 degree within the plane or perpendicular to the plane? Theo suggests that it's perpendicular to the plane and towards us. Anybody agree or disagree? So we have two different answers. Okay, so two people are saying into the board and one person out of the board towards us, away from us. Let's check it out. Remember that we are always, yep, right hand rule or the screw rule, yep. So we're doing A cross B, so remember we can move the vectors around, right? So we can move vector A and redraw it from the beginning of B. And we're doing A cross B. That means we're rotating from A towards B. This looks like counterclockwise motion, therefore we know it's positive, and therefore the direction of the cross product must be towards us, because the convention in science is to put x, y, and z with z going towards us. Okay? Any questions on this? So of course this implies that B cross A will be the exact same vector in magnitude, but in opposite direction, which would be into the whiteboard. Okay, what about its magnitude? Anybody can give me the value of its magnitude, or how to get it if you don't have a calculator. Blah blah times blah blah times blah blah. Or at least anybody can tell me which definition we're going to use. Oh yeah, looks good. AB sine theta. Yep, perfect. Since the angle given to us 30 is defined between the two vectors, then if we're looking for the magnitude, we can use AB sine theta. Perfect. Yep, I agree with Matt too. So, the magnitude of AB, which is the same as the magnitude of B cross A, will be magnitude of A times magnitude, well, let's use whatever is written, AB sine theta, in your case, 2 times 3, which is 6, sine 30, and sine 30 is 1/2. So the magnitude is 3. Okay? So whenever you're being given vectors in the form of magnitude of direction, and you're looking for the magnitude, feel free to identify the angle between two vectors, and feel free to use this nice little formula. Again, the trick is to make sure that the angle that you're going to be using in this functional form is really the angle between A and B, which is the case in this particular case. Okay? Now let's imagine instead of giving us A and B in such a way, we're going to be given A such as A is equal to 2I minus 3j, and B is equal to minus I plus 2j. Same question. I like to do A cross B. Now if I were going to ask you this exact same question, that is, what is the direction of A cross B? Is it into the board or out of the board? Then it's not so obvious to give the answer to that one, as it was obvious in the previous case. But we recognize that those two vectors are given to us in the form of the component notation, and therefore we know how to handle it. We're going to use the matrix, right? So if you want to calculate A cross B, we're going to set up the matrix I, J, K. Since I'm doing A cross B, I'm going to put my A vector first on the second row and B vector on the third row. So the component of A in the I direction is 2, the one on J is minus 3, the K is 0. Similarly, my B vector is minus 1, 2, 0. Okay? Then as I'm calculating the I component of those vectors, first of all, we're working in a two-dimensional system, and both of our vector A and B are given in I and J. So right away we know the answer is going to be in terms of K. We know the component of I and J will be 0. But let's just check. Again, imagine you put a current system across I, vertical line and horizontal line, and the 2 by 2 matrix that's left to us is minus 3 times 0 minus 0 times 2, using the fish method. So this confirms that the I component is 0. That's good. Then we're going to jump to the G. We also expect it to be 0. Let's check. If we put a horizontal line and a vertical line across the J component, then we're left with a 2 by 2 matrix, which is composed of 2, 0 and minus 1, 0. Similarly, as you calculate the determinant, you end up calculating 2 times 0 minus 0 times minus 1, which obviously is also 0. And then we can verify that the K is going to be non-zero. We put a horizontal line through K, a vertical line through K. Now the 2 by 2 matrix is 2 minus 3 minus 1, 2. Therefore the determinant is going to be 2 times 2 minus minus 1 times minus 3. So it's going to be 4 minus 3, that's 1. Therefore the answer is 1k, which is a vector going outside of the board towards us. Okay, any questions on this? questions? Ah, how did you get 1k? Ah, okay. Oh, maybe I goofed actually. Yeah, always check my algebra. I did the fish on this. So I put a vertical line across k, like this one, and a vertical line across k. So my 2 by 2 matrix is this one. 2 minus 3 and minus 1, 2. So at this stage I would like to calculate the determinant. And remember, to get the determinant, I'm going to take this number times this number minus this number times this number. So it's going to be 2 times 2 minus 3 times minus 1. This is equal to 3. This is equal to 4. And so 4 minus 3 is equal to 1. Is that correct? And I multiply this number by my k component. Okay, good. Any other questions? If you're a little bit rusty about determinant, because that's the convention of k. Remember, this is our I, this is our j, and this is our k. So if x and, I'm sorry, this should be y. My bad. If x and y are in the plane, like a and b, then the k vector is towards us. This is the current system, the standard current system that is consistent with the rule that we've seen last week, ijk, excuse me, ijk. So if you're going towards the right, I cross j will give you positive k, j cross k will give you positive I, k cross I will give you positive j. So if you go towards the right, it's positive. If you go towards the left, then it will be negative. So k cross j is minus I, j cross I is minus k, I cross k is minus j. This convention is consistent with this. If x and y are in the plane, then the z is towards us. Okay, good. Watch out, because I believe in some books of calculus, if I remember correctly, their convention is opposite. The z is like this, positive. If you see this, make sure you're able to adjust. But in science, physics, civil engineering, and ME, we all use the same convention, which is this one.